Hey,
Hello,
what's happening?
we're back again.
We are. I see your cursor's going all over the place here. Go ahead. Put it up.
Oh, no, sorry. It had
Can you write
a
on the board?
notification.
Can you write on the board? See if you can do that.
Oh,
I think you can. That's cool. All
can
right,
you see
nice.
it?
Well done. Well done. Excellent. Is
Oh
that
my
with the
gosh.
mouse? Is that with the mouse?
My gosh. Yes, it is.
That's pretty cool. All right. I'm gonna have you do all the writing then, since you're
Oh no.
mouse and writing. Is that okay? Or I've got a pad over here, so.
That's okay. I'll do my best.
All right. That's cool. All right, so we're going to talk a little bit about Bayes' theorem, right? After we talked about conditional probability.
We are.
All right, okay. So let's say we have, all right, I think these graphs may serve our purposes well here, okay?
Mhm.
I'm going to start off with a partition
Right.
of our sample space, okay?
Mhm.
So these are like three different pieces of our sample space that are there's no overlap. And collectively, when we put them together, there's nothing that's been left out.
Right.
Okay. So, all right. So here is an event that happens across all three of those partitions, I guess, or those three parts of the partition.
Okay.
All right. So as an example, okay, let's say we have pencil factories. We're creating pencils, okay?
All
And
right.
we have probability. Let's say this guy is called factory A, this guy's called factory B, and here's factory C,
Right.
okay? And let's say within those three factories where 100% of our pencils are produced, there's some that end up being defective. Okay?
Right.
So we might ask the question, what's the probability that a particular pencil a pencil came from a particular factory given it's defective? Okay?
Right. Okay.
Okay. So we have a collection of these defective pencils, right, that have been collected, let's say, and we see that it's defective, and we might ask the question, hey, what's the chances it came from the first factory? So that we might want to make adjustments if we can somehow to be able to kind of reduce the chances of having a defective pencil overall. That make sense?
It does.
All right, cool. So how can we do this? Well, according to our probability distribution, or sorry, according to our conditional probability, we can say, well, that's just the probability of coming from A and being defective. Sorry, let me undo that real quick. Let me erase that. Probability of coming from A and being defective.
Mhm.
All right. Sorry, being defective. Let me get rid of that little hash mark there because it means nothing. Okay. Divided by the probability of what was given, right? So the probability of D, correct?
Right.
All right, cool. So this is D. So basically we can say, all right, well, this bit right here is that reduced sample space in a sense, right? Since we know that we're in D, right? We
Mhm.
know that it's defective. And this guy would just be that intersection. Sorry, that's not what the intersection looks like. Sorry. That was
That's
from the
okay.
previous one. Let me give it a little bit more detail here. It would be this bit, wouldn't it? That bit there, right?
Yes.
So this bit is the same as this bit right here, right?
Nice.
Right. That guy and that guy are the same. Okay, so that's really what we're trying to find.
Mhm.
But this guy down here, right? Can't we say that this is just the probability of A intersect D plus the probability of B intersect D
Mhm.
plus, sorry, my handwriting's terrible, plus the probability of C. Probability of C intersect D, right?
Yeah.
Okay, all right. So we can kind of look at all of this in terms of these intersections, right? But if we remember from before, right, that probability of, as an example, probability of A intersect D, right? That can be looked at as a probability of A given D, right? Times the probability of D. Did I do that correctly? I think I did that correctly, right?
I believe so.
Okay. So, but this, right, this same intersection can be gotten to by first ending up in A and then multiplying that by the probability of being in D, given that I'm in A, right?
I get it. Yes.
Does that make sense?
Mm-hmm.
Okay, so if I've got information like this, I can figure out what every one of these things happens to be. Okay?
Mm.
So how might this help us in our particular example? Okay, I might say, all right, let me do this. I'm going to start with, let me get rid of some of this stuff here. And then I can put it back up as we need it, okay?
Right.
All right, just so it's a little bit cleaner. Sorry. All right, here we go. So what if I told you, all right, let me get rid of these here. All right, there we go. All right, so let's say that 25% of the 25% of the pencils are made in factory A.
Mhm.
Let's say 30% are made in B, and let's say the rest, which would have to be what?
0.45.
45%?
Yep.
So 45%. It's terrible.
Looks like a 95.
I know. 0.45. Come on. There we are. All right.
There we go.
Crisper lines there. Okay. So, and let's say we also know that the probability of being defective, given that they came from A, let's say that is, let's give it an amount. Let's say, all right, let's say it's an older facility. Let's say that 10% turn out to be defective if they come out from A. That's pretty terrible. Okay. Let's say that the probability of being defective given that it came out of B, let's say it's a little bit newer facility and we're only losing 5% of those as defective. And let's say finally we have the probability of being defective given they came from C. And let's say that's an even better facility. And let's go with what, 0.02, whatever it might be. Okay.
Right.
All right. So we have a distribution here, but let's see now if we can figure out what the probability of the pencil coming from A, given that it's defective, right? Well, we can say that it's the probability of being an A times the probability of being defective while being in, given that it came from A,
Mhm.
right? That would be just this bit, right?
Right.
That puts us into that intersection, doesn't it?
Mhm.
Right? Over, well, we need the other two intersections, don't we?
Mhm.
All of them. So the first guy is exactly the same, right? Because it's this bit, right? Over this bit, right?
Mhm.
That's exactly the same. Probability of A given the times the probability of being defective given it came from A,
Mhm.
plus the same thing for B, right? Oh, this is where it gets tough. Oh lordy, there we go. Okay. Probability of being defective given that it came from B. And then finally, I'll add the C bit down here. Probability being in C times the probability of being defective given it came from C.
Right.
Okay?
Mhm.
So that happens to be, right? This guy, here, let me see. Let me try to set it up here with some color if I can. Okay. This guy times this, all right?
Mhm.
The next guy would be what? Let's try this one times this, all right?
Mhm.
The last bit would be what color? Blue, let's try. This guy times this are the three pieces that make up this whole fraction here, right?
Right.
All right, this guy is here. Sorry, now it's going to be tough getting the same colors as this guy is here. I think that's the same. And then the first one was in what, red or pink or something?
It was. I think you've got the wrong way around.
Did I screw it up?
I believe the blue one should be the very last.
Oh, I'll fix that in just a second. Hold on.
All
Let's see
right. Okay.
that magically. Hold on. Let me do this last. No, I screwed it up, man. I did. Let me get rid of it. How embarrassing. All right, let's try it one more time. Where's the color? All right. So the red one I'm doing now. So we agree that this is the red one,
Yes.
right?
Cool.
Nice. Thank you for that.
That's okay.
All right, what would I do without you?
I'm always on the lookout for you, George.
Oh no, what am I doing?
Oh, hang on.
Unbelievable.
Oh, technical
Even with,
difficulties.
even with your help, I'm,
Please stand
I'm
by.
helpless. All right, let's try that green again. Here it is. It's this guy. Oh, it's a different shade of green. Is that it?
Yeah, that's it.
That's one, and let's do the blue one. So you don't give up. I don't give up in what was it? The blue one? No, the blue one. The blue one. Blue. This guy. Right?
Yeah.
That was exhausting.
Oh, you did so well.
Thank you so much. Should we just leave the calculations to the audience?
Yes, we'll do
Or
it as an
should we?
exercise.
All right, that's cool. They can worry about that.
Put your
All
answers in the chat below.
right. Yeah, that's right. All right, Laura, thank you so much.
That's great.
All
Thank
right,
you.
that was fun. That was fun. I'm glad. All right.
Yes, I love
See you
learning new
next
things.
time.
All right.
All
Bye.
right.